Wait, just before we start this video, I have a few editor notes to this. First off, thank you for clicking on this video. Thank you for checking me out. I just wanted to give a couple disclaimers first. First off, I am a student of physics as well. I am learning this as I'm doing these videos, so please do not come after me if I make a mistake. I am trying my best here just to help try to explain physics from a student's perspective. Also, fun fact, there are some mistakes in this video. That is why, in the link down in the description, I should have posted a PDF with all the work that I did with all the errors corrected. I don't have the paper with me right now, but I believe number 7 and number 5 are incorrect. Not like too incorrect, like the physics is wrong, but I might have like miswrote a number. So please, if you want to follow with me, listen to me while also looking at the PDF that I posted down below. Past that, I hope you guys enjoyed today's video, and I do promise you I will get better as we go on. Thank you. Recording. Hello. Good afternoon, everyone. I'm Backseat Physics, and well, as we can see, we got some physics problems. And well, as everyone can tell, first video, I'm going to try this to the best of my ability. But anyways, let's get into the physics problem. First one, number 1, it says, what is the kinetic friction force on an object of mass 37 kilograms as it moves over a surface where the coefficient of friction equals 0.22? Okay, so we know that we have a force going in one direction, and we have friction counteracting it. That's why we set up a problem where force is being subtracted by force of friction, and we set that equal to mass to acceleration. I also do apologize about the crappy handwriting. I'm still trying to figure out how this stylus pen works. Okay, the force we don't exactly know, but of this problem, actually I will admit for number 1, I am just a tad bit confused. And this is my first disclaimer of this channel. I am also a student taking physics. I'm also sorry about how this might get. I am a student of physics. I am still learning this as I go, so please do not take this as the gospel of physics. I am no Sir Isaac Newton. I am just trying to understand physics and help my friends with it too. Anyways, so what I've picked up on this problem is that when it says kinetic friction, that means our acceleration is 0. So basically, how we can say this is the force is equal to the force of friction, because we can say this is equal to 0. We have force of friction on both sides, and we eventually get force equals force of friction. Now we know force of friction is equal to mu times Fn, and as this is we can assume if this is a horizontal surface, that means force of friction normal force is equal to force of gravity, and force of gravity would be 37 times 10, and we multiply that by 0.22, and realistically I should have brought a calculator with me. I will be using my phone in the meantime before I get, oh snap, I think I left my calculator in my car. If there's a random jump cut, it's because I realized I need to use an actual calculator. But for the meantime, I can just do 0.22 times 37 times 10. That'll give us 81.4, and that's our answer. I think it makes sense, hopefully. Number 1, I do apologize for not knowing it completely. There might be a revision to these episodes later on when I understand these better. So we're going to say force is equal to 81.4 newtons. And I am back. I do apologize for a random cut. I had to go grab my calculator. And I also contacted a friend, and they did confirm that for number 1, we're supposed to assume that acceleration is 0 in this because it's moving at a constant speed. And when we do that, we have force is equal to force of friction. Force of friction, as we know, is mu times normal force. Normal force in this situation, because it is on a horizontal surface. Here, let me draw a diagram of what this should look like. If I can get my pen to work. I do apologize about that. Okay, here we are. Okay, why is this oh. Again, apologize. My thing was backwards. My drawing tab was backwards. Okay, so this block is on a flat surface, meaning when we draw a diagram, we have normal force going up, gravity going down, a force going this way, force of friction counteracting. And we're going to assume that this force is greater than friction, or I guess technically in this case, we're going where force and friction are exactly the same because it's moving at a constant speed, meaning acceleration is 0. So we add force of friction on both sides, force equals force of friction, and then all the other stuff I just said. Again, I apologize for number 1. That question kind of confused me. But this one I understand a lot better. So this one, oh my god, this should be a lot easier to do. And again, I do apologize for all the technical errors. This will get better eventually. Okay, so I don't know why I keep doing that. A 2 kilogram block slides down a rough surface on an incline of 25 degrees. So let's first draw this. So we have an incline. We have a block on this incline. Again, I am also no drawer. So we have, technically, and there was no force being acted on it directly, the force of gravity would want the block to go down. So let me also just draw that out. So we have normal force, which is perpendicular to the surface. Again, surface not very well drawn out, but you get the gist of it. And then we have force of gravity both perpendicular and parallel, and we need to focus on both of them in this. Here, let's also just draw a free body diagram to better visualize this. So we have normal force. We have force of gravity, technically in 2 directions. We have this is technically also still just force of gravity parallel, and then we have force of friction. Nice. From here, we can now set up our equation because we were looking for a coefficient of friction. So we have force of gravity parallel minus force of friction. Oh, I forgot. It does say with a constant speed, meaning force of gravity parallel is equal to force of friction, because if we add force of friction on both sides, we get Fg parallel is equal to force of friction. Now from here, it's really simple. All we have to do, we figure out what force of gravity is. That is, or force of gravity parallel, which is m, so 2, times gravity, which in our case is 10, sine, because it's force of gravity parallel, of 25. And we set that equal to mu force of gravity. Okay, so as we know, force of friction is mu normal force. We're going to ignore how I wrote that. Sorry. But we know that normal force, because it's on an incline, is equal to force of gravity perpendicular. And the formula for force of gravity perpendicular is mg cosine of theta, which is 25. Quite messy, but to simplify, we have force of gravity parallel, 2 times 10 times sine of 25, and we set that equal to force of friction, which is mu, which is what we're looking for, times mass times gravity times cosine of 25, also known as force of gravity parallel. Now I'm going to go grab out my trusty calculator. You guys should do this at home if you're following along, and smack in the numbers. 2 times 10 times sine of 25. So the left side of the equation comes out to, if I can find it, we're going to write this over here. 8.5, I'm rounding up. And the right side is equal to 2 times 10 times cosine 25, which is 18. 18.1 mu. And that's simply, we just divide both sides by 18.1. So we got 8.5 divided by 18.1, and that means our coefficient of friction is equal to 0.47. Okay. Alright, and now, hopefully with number 3, I can make this look a bit neater. They don't give me much space here, so I might try to, like, I'll try to figure out a different way to write this out, just to give myself some more space, and maybe make it look a bit neater. But, hey, this is a work in progress, and you guys are coming along with a journey. Can I write over here? I cannot. Okay. So, we have a 2 kilogram block, accelerates up an incline, so that means we gotta draw that fun triangle. Let's see, can I make this square better? Yes, I can. Good enough. Okay, and it's accelerating, meaning we have a force going this way at a rate of 0.5 meters per second squared. The coefficient of kinetic friction between the block and the incline is 0.15. That means we have friction going this way. Finally, we have normal force going up, and we have force of gravity doing its thing, both perpendicular and parallel. Okay. Now, I'm going to skip the free body diagram. Oh my god, free body diagram part. I apologize. You can kind of just see it in the triangle. We're going to go straight into the equation. So, as we know, we have a force that's moving it up, meaning that is our bigger force. I probably should have said this a bit earlier, but from all these questions, for all of like the sum of forces, how I like to set up, I like to have big force minus little force, which is equal to mass times acceleration. So we have big force, which we're just going to call F because we don't know really what it's called, minus, now we're going to have two forces here because we have both force of gravity parallel, trying to pull it down, and we have force of friction. So I'm going to say force of gravity parallel plus, because we're both working together to pull this block down, force of friction, and that's equal to mass times acceleration. Force, we still know what it is, so we're going to keep that over there. And we're going to add this entire part to there. So we have our mass is 2. I'm sorry for very ugly 2. We know our acceleration is 0.5. Sorry, my hand's slowly starting to cramp up. It's very hard writing all this. And we have 2. Okay, so because force of gravity parallel is, again, mass, which is 2, times force of gravity, times sine of the angle, which is sine 25. And then we're going to add that to our second part. Oh, I forgot we are adding these. And then force of friction, as we know, is mu times force normal. And force normal, and if it's on the incline, is the same as force gravity perpendicular, which is 2 mass times gravity times, we're going to write it down here, I'm sorry, cosine of the angle, which is 25. So now, take out your trusty calculator and just start writing down some numbers. So we have 2 times 0.5, which is 1, plus 2 times 10 times sine 25. Oh, sine 25. Sine 25 being like 8.45. And now we're going to... I do apologize for the cut. I kind of just forgot how to do some easy math. So I forgot mu over here is given to us. It's 0.15. So now we do 2 times 0.5, which is 1. And then we add that to 2 times 10 times sine 25, which for my calculator is 8.5. So now we have 1 plus 8.5, 9.5. And now we add that to mu, which is 0.15 times 2 times 10 times cosine 25, which comes out to 2.7, giving our total force, our total applied force is equal to 2 newtons. There we go. Okay. I might, at the end of this, rewrite all this on paper a lot neater, and I'll add a link on the bottom to it if I can figure out how to do that. Anyways, let's move on. A light fixture of 6.8 kilograms is held to the ceiling by 2 massless cords. The cord on the left makes an angle of 62 degrees with vertical. The other cord makes an angle 39 degrees with vertical. Find the tension in each cord. Oh, this one's a fun one. I just did this one in class myself. So we're just going to draw a square. Let's pretend it's a light fixture. And we have 2 cords, I think they said. Yeah, 2 cords held up on the ceiling. So if we want to draw this as we could draw this as a vector. We have that. We have force of gravity going down, and we have a tension of these 2 cords. Now, I'm personally going to use my mouse on this one because this is a lot of details that I need to write out. So I need sort of more precision, It might look a bit messy though, so it might take a bit longer. I do apologize on that. So we know that tension 1 cosine of the angle, because in this situation, it's a bit hard to explain. Actually, no, I can explain this. So we can technically see each chord as this, with this angle right here being the theta. And then, since because this is the chord that we want. Wait, hold on. This this part of the video might have seemed a bit weird. This is a lot of editing I'm going to do now, and a lot of weird jump cuts. I do apologize. But to explain as to why we use cosine instead of sine, it's because we're looking for this line in particular, as because cosine deals with the adjacent, not the opposite. We use cosine in this situation. Now, a lot of other situations, especially if it's in a vertical, we'll use the y, which would be sine. But just as like a word of advice, if it says 62 degrees with a vertical and you know it's going to look like that, use sine. Again, I do apologize, but I don't have a better explanation. Okay, now we have t2 cosine. Actually, this is supposed to be 62. Yours is supposed to be 39. Forgot I'm going to use my... And we set that equal to... Okay, sorry, I should have probably explained this a bit better. Since because these two chords right here, and it's... Okay. Oh my god, wow, this is going to be a lot of editing for me to do. Nope, I'm going to explain this right now. So technically, we can see this problem as t plus t minus g is equal to ma. However, because ma is equal to 0, because it says two massless chords, and... Okay, we know that because it's being held to the ceiling, we know that the object is not moving. Hence, acceleration is 0, meaning we can set this entire thing to 0, which means we can add gravity onto both ends, so the force of the two tension chords is equal to gravity. I'm sorry if it took me a lot of time to explain. I'm going to undo all this I wrote to give myself more space. Okay, so we have tension 1 cosine, because we only worry about the y direction in this case, plus tension 2 cosine, y direction of the other chord, is equal to the force of gravity pulling down on the object, which, so that's 6.8 times 10, which is just 68 newtons. Now, since because we have technically two variables here, and we don't know what either of them is equal to, we're going to now look into the y direction. So we're going to like kind of cut this off, and I'm also going to erase that, because we don't need that now. And so what we can do is, you could say T1. Oh, sorry, I should have explained this a bit better. So as you can see here, we technically have two vectors on this end. We have vector here, we have a vector there. Now we know that the two y's, or the two like vertical of the vectors, equal to the gravity. However, the two horizontal vectors just have to equal to themselves. Sorry, to put this in better terms, this is because we could say that T2 is going in the positive direction, and T1, because it's going this way, T2 is going this way. No, sorry, T1 is going this way. We can say T2 minus T1 is equal, because the object is not moving, it's equal to 0, meaning T2 is equal to T1. So, knowing that knowledge, you could say T1 sine of 62 is equal to T2 sine of 39. Okay, and now what we could do from here is we can divide both terms by sine of 62. That gives us, I'm going to write this over here because we need a lot of space for the rest of this. T1 is equal to T2. Sorry, I should probably write that out. T2, and then now we got to do sine 39 divided by sine 62. Okay, so we have 0.7 T2. Where is... Okay, I can't find where my pen is. So we're going to do 0.7 T2. And again, this all works because we're trying to find the y value of these two chords because they're the same as gravity. But since because we have two variables, we can't solve it until we get one variable by itself. We can do that by going to the x direction because the x value of this chord is the same as the x value in this chord, as since because they're in opposite directions and they equal 0, you can just move one of the variables onto the other side. So we get t2 is equal to t1. And then because it's the x direction on a relative to a vertical, we have to use sine instead of cosine. I know, it's a bit weird. I'm still trying to wrap my head around it myself. So when we do t1 sine 62 is equal to t2 sine 39, divide sine 62 on both sides, so we get t1 is equal to 0.7 t2. I hope I explained that well enough. And then from here, we're going to have to write this quite small. So instead of t1, we could replace that by 0.7 t2 cosine 62 plus t2 cosine 37 is equal to 68 newtons. Now from here, we can simply just smack in our calculator. So we're going to do 0.71 times cosine 62. We're going to add that with cosine, I forgot to put cosine on the other side, but make sure it's cosine 37. So we get 1.13 t2 is equal to 68 newtons. So we divide both sides by that. And we get our total is 68 divided by 1.13. So that means our force in T2 is equal to 60.17 newtons. Now, knowing this, we can plug 60.17 back into our original equation. So I'm sadly not going to be able to write this down on here, but I'll just say it out loud. So we have T2, which is 60.17. We'll multiply that by our cosine, so times cosine of 37. So that gives us 48.05. So now we're going to do 68 minus 48.05. So now we have T1 cosine 62 is equal to 19.95. Now we simply divide both sides by cosine 62. And that gives us T1 is equal to 42.5 newtons. Okay. Alright. I think I'm getting a little bit better at this. Who knows? A couch of a mass of 210 kilograms is being pushed with an applied force of 1,000 newtons. The coefficient of static friction is 0.5 and the coefficient of kinetic friction is 0.38. What is the acceleration of a couch? Okay, before we can find the acceleration, we have to know if the couch can even move. So we can set it up as the force, which in our case is going to be 1,000 newtons, minus force of friction is equal to mass times acceleration. So the mass in our case is 210. I don't even know if we even need this part. I'm going to be completely honest. I think just the force needs to be greater than the force of friction. So we don't even need it actually. I'm just going to undo all that. So we just need to see if force is greater than or equal to force. Actually, I think it just has to be greater than. I'm not 100% positive. So our force is 1,000 newtons. But we're going to undo most of this so I have enough space. Now to find force of friction, we know that as 210 because it's mass times gravity, which is 10 times 0.5. Now if we smack that into our calculator, we got 210 times 10, which is 2100 times 0.5. It's 1,050, meaning we can't do this problem. So there is no acceleration because it can't move at all because the force of friction is greater than the force, because that is equal to 1,050. And so 1,050, which is force of friction, is greater than 1,000 newtons of our applied force. There we go. That was easy enough. Okay, so the same question, except now we have a lot more force. This is because we know, because it's the same exact weight and same exact force of friction, and we know we needed at least 1,050 newtons to push it, and we're giving us 4,100. We know we can do this off the bat. So now, instead of using the static friction, since because we know that this couch will move, we're going to use the kinetic friction. So we're going to set this up as force. Okay, let me use the pen for this one. Force minus force of friction is equal to mass and acceleration. Force being, those should be zeros. 4,100 newtons minus force of friction, in this case, is going to be 0.38 times 210 times 10, which is equal to 210A. So we're going to now plug in these numbers to our calculator. So we're going to do 4100 minus 0.38 times 210 times 10, which gives us 3,302, no, 2 newtons is equal to 210A, divide both sides by 210, divided by 210, and we get acceleration is equal to 15.7 meters per second squared. Okay, we're on my final question. Oh, thank God. Oh, my voice is hurting. And I still have to edit all this, and I might have to redo this entire thing because this is kind of sloppy, I must admit. Anyways, ignoring all of that, let's continue on with physics. A box of mass of 29 kilograms is being put up a rough surface incline. So that means, off the bat, we have a triangle, which is given to us, but I want to draw my own. I don't like what's given to us. So we have a triangle, we have a box on said triangle, and we have a force pulling it up. And we also have a force pulling it down because of friction. We also have normal force, as always, and we have good old gravity. And it's 2 parts. So, they first want us... Okay, actually, sorry, let me read the question. Let me continue reading the question. So, we know the applied force is 370 newtons. And we know that the kinetic force is 0.21. First question, they want us to find FG parallel. Actually, let's do this more up. Let's do it like up here. We have FG parallel and FG perpendicular. It wants to find FG parallel, as we know, is mass, which is 29, times 10. That's a 10, I swear. Times sine of 42. Okay, smack this into our calculator. We do 29 times 10 times sine of 42. That's equal to 194 newtons, where I'm rounding down. 194 newtons. FG perpendicular, 29, again, because it's mass times gravity times cosine. I'll engrave that into your guys' brain by the end of this. So it's 29 times 10 times cosine of 42, and that's equal to 29 times 10 times cosine of 42. That's equal to 215.5 newtons. Yeah. 215.5 newtons. Find the value of the normal force. Now, as we know, normal force is usually equal to force of gravity, but since because it's on an incline, normal force, or Fn, is equal to force of gravity perpendicular. And we've already found force of gravity perpendicular as 215.5 newtons. Find the value of a kinetic friction force. Find the value of a kinetic friction force. Oh, I'm sorry. That's just simply, it's asking us to find friction. Force of friction is equal to 215.5 newtons times 0.21. 215.5, right? Yep, times 0.21. So the kinetic friction force is equal to 45.255 newtons. There we go. Now we're almost done. Now we need to make our system of equations. So some of our external forces is simply the applied force minus. Now we have actually two forces counteracting this. Because let's say that this was a frictionless force or frictionless incline instead, we would simply just have force of gravity perpendicular acting on it. Because if you have anything on an incline, its optimal direction would be going down. So that means gravity is pulling it down. However, we also have friction being applied on this, and friction goes against the applied motion. Sorry, the applied force. So it's because our applied force is going this way. We're going to consider this the positive direction, and force of friction and gravity are both in negative direction. So we have applied force minus force of gravity parallel plus force of friction. And that's all equal, you can't forget this part, ma. Again, we have big force minus little forces, because there's two, and we set that equal to ma. So now we know the big force is 370 newtons minus force of gravity parallel, which we found to be 194, plus force of friction, which we found to be 45.26. We're going around. That's equal to 29a. So now we're going to do some good old-fashioned calculator work. So we have 370 minus, I'll go put this into parentheses in my calculator, 194 plus 45.26. That's equal to 130.74, and we divide that. So, sorry, we have 137 oh my god, sorry, again, we have 130, I'll just write this. We have 130.74, we make that equal to 29a, divide both sides by 20. I don't know why it's like diagonal now, like we're writing, but we're going to go with it. So, we have a is equal to 130.74 divided by 29, and that is 4.5. So our acceleration is 4.5 meters per second squared. Okay, that is all for today's first episode. I do apologize for the sloppy handwriting. I will try to figure out this tablet better. And if I did mess up any terminology, or if there was any mistakes, please let me know down in the comments below. And if I didn't explain something well enough, also please leave a comment down below, and I'll be there to help explain. Anyways, that's all from me, and I hope everyone has a great day. See you.